Okay, Assalamualaikum and good afternoon. Can you hear me?
Waalaikumsalam. Boleh ke?
Boleh.
Boleh. Okay, alright. How are you? How are you? Sihat ke semua? Sihat ke semua?
Alhamdulillah sihat saya.
Okay, Alhamdulillah. Okay, like I mentioned just now, so this is the last gift. My last gift to all of you. Okay, quiz 3. Okay, quiz 3, quiz 4, and assignment. Okay, so already open from today until for the quiz 3 until Wednesday night, and for the quiz 4 until Thursday night. And then the last one is the assignment. So the assignment, the deadline is 11 February in Friday. Saya tahu masa tu is your final exam. But ada plus kat situ lah In case ada plus tu boleh adjust lah Not fixedly at 11 February lah. If you need some time after that, I think I can consider lah maybe. Okay, ini for the purpose of the assignment, so make sure you do this as the same group members, and make sure you understand the flow of the assignment. It's about the grid connector design. Okay, because it's also if we do within this season, I mean submission before the 11 February, before the final exam or during the final exam, I think your paper on 8 kan? Betul? 8 February kan? I think at the teenage final exam is 8 February
Betul.
So for me, it's the right time for you to study together with the final. For the final also, at the same time you submit the assignment. So make sure you clear. I'm afraid if we do earlier, bukan sebab saya malas nak bagi awal, if you do earlier and forget, you already forget. So if we submit within the final exam season, I think the better one is you to submit the assignment before your final exam. So at least I can check. Okay, I can check your you can study together kan. Study sekali dengan untuk preparation final sekali lah. Sekali dengan assignment. Okay. We finish until the chapter 5, grid connected standalone, everything finished. It's actually we only need another one chapter. We see that one chapter will definitely not coming out in the final maybe. Also no quiz, no test, no assignment, no lab. Regarding the sixth chapter, the last chapter that I want to start now. And I don't have very specific notes for the chapter 6, but because the element of chapter 6 is about hybrid system, energy management, and the smart grid, which is the application. I think it's enough for you just to read, just for your information, or just for your additional knowledge. It's not specific coming out in the final exam or any assessment. Okay, so assume this is only for fun today. Kelas ni hanya kelas yang kemungkinan this is the last class, maybe this is the last class, or the very last class on Mondays. Actually, I want to teach you about the PVCs, but depend on the condition. I want to teach you about the PVCs, the use of the PVCs too. Also in the next class only for the PVC session, but I'm not sure. So maybe the last class will be on Monday. Means that this Wednesday. Okay, this Wednesday, I think on Thursday is the PSM1 seminar, betul? Betul tak? Thursday.
Betul, sir.
Berapa ramai yang terlibat? Berapa ramai yang terjejas dengan PSM1 seminar? How many of you? You, angkat tangan sikit. 2 orang lah, tak banyak. Ramai ke yang terjejas? You. Ramai golongan terjejas, ramai juga lah. Okay. Ada lagi yang tak angkat tangan? Ada lagi ke? Nimala ke, Fatin ke, Aisyah kan? Ramai ni. Okay. Okay lah. Wednesday tak ada kelas. Okay, Wednesday tak ada kelas. I give you time for you to prepare for your presentation lesson 1 seminar. So the last class maybe Monday or maybe no class. If no class, maybe I will paste some video something like that if capable lah. So, saya pun tengah busy kan. Sebab PVC tu tak adalah syllabus kita pun. Tapi saya macam nak ajar awak jugalah kan. Nak sharing jugalah untuk buat PVC tu. But tak boleh janji 100% lah. Kalau saya capable, saya beritahu, maksudnya ada kelas lagi Senin. Rabu depan memang tak ada kelas lah. Next Wednesday there will be no class anymore. Actually cover chapter today finish already. Expectation today already finish the final chapter lah. For the PVC tu kalau sempat Senin depan, kalau tak sempat tu whether saya buat asynchronous ataupun tak sempat langsung. I will inform you lah. Okay. So today's for today chapter or for today what we call that today teaching maybe will more to santai-santai dan baca-baca, tengok-tengok sikit-sikit macam tu lah. Okay, we are not going very seriously. Okay, not going very seriously. Tapi kalau lepas ni ada soalan bolehlah tanya. Alright. Okay, like I told you in the last chapter this about hybrid system, energy management system. Okay, energy management system and the ini apa ni? Smart grid. Like I told you, we don't have any specific notes because most of this is what we call the latest trend of the research or any works that relates to the PV. It's all about PV, everything related to the PV. Hybrid system. Before I just pick any example, actually I'm using the Science Direct. Ni for the fourth year should know lah kan. Mesti dah tahu kan. Cuma kau nak refer literature review kan. It's all about literature review. For those who study about the PV, kalau hybrid system, you just Google it. For example, I just put the PV hybrid system. You're going to see lots of tons of works or journals related to this. Okay. Ini tahu kan Science Direct kan? Saja nak action tu ni awak. Ni you boleh solve kan? Tahu kan ni energy ke apa benda ke? Then you can solve by ni. Ini you can access using your easy proxy. So today I'm just like promoting lah. Today I'm promoting, not lecturer. Okay, this is a hybrid system. When we say hybrid system, by definition for me, PV hybrid means other than PV, there will be another energy sources that integrate together with the PV system, most as a main or as a base system. Faham? Maksudnya PV tu mungkin dia boleh hybrid dengan wind. It can be hybrided with the battery also. You can hybrid it with the ocean energy, or you can hybrid it with the genset, diesel power generator. It's all about hybrid lah. But most cases there will be PV as the main source of energy resources, and then there will be the backup for the storage banks. They have the batteries, and sometimes they have the wind energy there. Wind energy, and sometimes also they have the genset or the diesel generator yang tarik depends lah, 6 kVA, 4 kVA, or for those who are doing the internship in the company that related to power, sometimes they bring you at the control room and panel room yang ada genset tu. So it's about the hybrid system tu memang ada genset. Sometimes they use the UPS, uninterruptible power supply, also batteries as the interval backup source, very temporary backup source. Okay, saya bagi contoh satu tu senang. Ini ya, boleh kita buka ini. Alamak. Okay, saya bagi contoh dengar ke saya cakap apa, ke saya cakap seorang, ke saya macam ni?
Dengar.
Santai lah, sambil nak makan ke minum ke, boleh ikut pandai mu lah. Saja nak tunjuk lah, kalau in case lah kod-kod ada berminat nak pergi lebih jauh kan, nak tahu pasal hybrid system. Which hybrid system tu by default yang saya sebut tadi, tapi kalau tengok journals tu memang banyak lah, macam-macam jenis yang dia buat. Okay, ni contoh paper, saya ada ni lagi. Saya ada journal pre-proof lagi, ni memang latest ni. Kenapa dia upload ni? Okay, tak apa. Contoh journal, kita besar sikit. Kita besarkan sikit. tak ada soalan. Okay. Oh, ini ada IB characteristic. Okay. Okay. Ya, tengok So ni, here they have the PV panels. Okay, PV panels, I believe this is the one of the main resources lah. And yet, they are the one, wind turbine. Okay. And wind turbine, there's in the converter controller, but it's different charge controller. Yeah, just for your additional knowledge or information, for PV panel, usually we have the charge controller. Okay, charge controller call as charge controller, and together with the inverter maybe, we call that as Sunny Boy. Sunny Boy. You can Google ni, you can dapat Sunny Boy. Lepas tu, and then wind turbine tu, if I'm not mistaken, Wind Boy kot maksudnya. That's the for the charge controller. But here they have the PV panels, and they have the wind turbines, and the power is stored in BSS. BSS is equal to battery energy storage system. Okay, and then they have the load here, and the middle here is converter, maybe inverter, also controller, everything, and so on. Okay, and the PV is coming up, of course, from the irradiation, solar irradiation yang you buat lab satu tu, you buat lab tu. And then the wind turbine, lab tak boleh tanda lagi. Okay, wind turbine is the wind speed. Sometimes they use the FM software, something like that use the wind study kan. So ni maksudnya PV wind dah hybrid already. Basically memang most of the cases they're going to have the battery energy storage lah, of course. When we go for hybrid system, logically you can imagine if you are landed, if you buy one piece of land or one piece of island, we don't have the physical connection of TMB, and we don't have the physical connection. That's why you need to establish your own generation system on the island. So from there, what should you do? You're going to install your own PV system. You're going to use the wind turbine, and you're going to have a storage banks, a huge storage banks in order to survive, so that you can get electricity, something like that. So that's the logic of using the totally standalone system or the hybrid system. And at last, if we full with cloudy or rainy days, then there will be no wind, for example, because rainy may be difficult for the wind turbine for the wind blade to rotate. Sometimes because of the heavy rain, it will be stopped. So last backup is to use the diesel generator, or we call the genset. So genset to last call lah. So they have the tanks, then you have the diesel there. Finally, you use that. But that one it cannot withstand for several longer time lah. The backup system, the genset one usually several hours before the wind or other things is there. But if the worst case, then you need to you need to have the diesel lah. Diesel is last backup lah. But mostly you're going to use the renewable energy lah, which is the wind and the PV. Hybrid doesn't mean all renewable because the genset is not renewable because we use the diesel. It can be mixed. Okay. Ni contoh lah. Kalau tak puas hati ni, rasa nak baca lagi, boleh lah baca. Ini mungkin saya rasa simulation study. Okay. Betul ada lagi lah battery life yang lain. Lama kalau benda semua. Okay. So that one is PV hybrid system lah. Ini apa? Thermal PVT, PV thermal, solar PV. Yang ni sama enggak? Wind PV. Okay, wind PV. Ni hybrid idle power energy and solar. Ni contohnya. Tak lama kelas ni tak lama, insyaAllah. Sabar. Sekejap, tengah loading. Ayo. Okay. Hari ini we are going to shop. Okay. do shopping with the journals so that you get used to that. Okay. Hybrid hydropower energy recovery and solar energy system. Okay. PET PV. Doing. Under varying energy demand in the agriculture sector. Okay. And then kita tengok sistem dia. Energy charge control, solar controller, inverter housing. Okay. They have the PV modules there, they have battery banks, okay, and then they have the diesel generator. Okay, diesel generator. So ni dah bila when combine more than one energy resources, regardless renewable energy or non-renewable energy, it's already considered as hybrid. Okay. Ni dia ada tahap apa dah? Mitigation, okay. Dia ada PET system dan sebagainya. Ini contoh paper lah, contoh paper. Tak semestinya kena ada macam ni. Okay. Alright. This is all about PV hybrid. If you want the detail, then you can Google, tengok YouTube ke, ikut pandai lah. With saya, we don't have specific because it's always changing. If you read the new paper, there will be the new idea there. So, boleh Google benda ni. Tak keluar final pun. Maksudnya tak keluar pun. Sebenarnya lah. Itulah. Kalau keluar pun, what is the hybrid ah? It's all hybrid. What is that? Okay. Next, energy management system. Okay. Energy management system also based on PV because what we call that? Apa nama? To make it easy to understand, when we do PV, PV photovoltaic, our main enemy is not enemy lah. Our main obstacle is the weather, It's the clouds, is the rainy or not, cloudy. So that's the one of the main important obstacles for the PV generation system. Okay, so usually when PV they embed or they integrate together with the batteries so that all the stored energy, all the energy generated through the PV will be flown into the energy storage batteries or battery energy storage system so that the generated energy will be reserved in the batteries, will be buffer in the batteries so that we can use during the night or other days. Okay, once we charge the battery using the PV generated energy, then we are going to have the backup if something happen in the future. That's why we need the battery. Okay, what will happen when the temperature is not good? So we are going to utilize all the energy from battery, right? In order to use that energy from the batteries, we cannot just simply use that and finish. Because, for example, if we are facing a longer days of the rainy season like before, and always raining, heavy rain, we need to have the very sufficient or adequate energy storage size. We need the adequate energy storage size so that we can withstand for several more days before the help come. Untuk flood punya victims kan. Macam tu lah. So, in order to do that, there will be algorithm or there must be, we need that kind of algorithm or control to control the flow of the energy, to manage all the energy, storage energy to the load. If we have generated how much, that there's a mechanism or the system that we need in order to control and manage the energy properly. That's why here comes the energy management system. So that the stored energy will not fully wasted. It will be controlled, will be managed wisely and effectively. That's why here comes the study of energy management system. For example, supervisory energy management of a hybrid battery, PV, tidal and wind source. Ini memang dilangsam habis. Ini the best example lah. But I'm not sure is it really simulation or the hardware level. Let's see. You okay ke? Okay, Devarajan?
Okay, sir.
Yeah, dengar je lah. Ilmu. Okay, this one, energy supervisor and management, hybrid, battery, PV, tidal, wind, semua dia tapau. Okay, tapau semua. Ni okay, ni calculation lah. Okay, calculation. Okay, tengok dia punya skirt dia. Tapi ni simulation label It's not the real implemented one. Okay, you see? They have the battery banks, of course, to buffer all the generated energy. Let's say it's all connected. Tengok betul-betul dia connected kat sini. And then PV panel, and then there the wind turbine, and there's a tidal turbine. Tidal ni from the tidal wave energy. So wave energy kan boleh Google yang dia naik turun. So there's turbine there, so that it can generate. Itu kan. Wind tu the blade, okay, wind blade. Okay, the wind turbine and the wind blade. So there's PMSG is the permanent magnetic synchronous generator, if I'm not mistaken, PMSG. So if I'm not mistaken, so there's a design of tidal turbine and wind turbine and so on. So there's a load there, variable AC load to smart university. So there will be the management system there and all the control there. Okay, and it's all about the MPPT algorithm. That's why they use the algorithm. For this case, they use the MPPT, maximum power point tracker system, algorithm of the wind system and the tidal conversion system. And then they have the converter and so on. So ada the calculationnya. And then there's the battery there, and then there's this control here. Okay, the control here. And then absolute system, blah blah blah. Okay, there's control here. Usually when they say energy management system, there will be the control system there. Maybe related to the PCS. If we learn principle of control system, maybe they're playing with the algorithm. Fuzzy logic. Okay, fuzzy logic sometimes use also artificial neural network sometimes. But fuzzy logic and then genetic algorithm maybe. Saya memang petik je contoh. And even sometimes also the new algorithm apa tu? Particle swan ke? Quantumization, PSO, or they use the mock flame, and so on. All the control is there in order to manage the energy properly because they have a lot of energy resources, then they need to control it. So they can manage so that the energy can be managed, or they can control the state of charge of the battery very well. Throughout several days, it can withstand for several days, for example. So that's the necessity of doing the energy management system that will be based on PV. Everything is PV based. And then the backup is wind and the tidal. Wind, you need to have wind, and the installation of the wind turbine also, wind energy also, you need to have if I'm not mistaken, 4 meter per second of wind speed minimum in order to generate in order to install the wind energy system in certain place, you need to have the minimum wind speed of 4 meter per second, if I'm not mistaken. Boleh check. Okay. Talking about anemometer, we will go site visit So site analysis, if we plan to install the wind turbine. Okay. That's the management system Tu contoh saya bagi satu. Lepas tu, cepat habis ni. Yep. Okay ke Aisyah?
Okay, sir.
Nimala?
Okay, sir. Okay. Sorry, sir.
Jauh lah tu dia. And then energy management ada lagi. Pakai control. There will be the control algorithm there in order to manage the energy that based on the PV Ni boleh Google. Saya cakap tak ada spesifik. Kalau if I do some notes tu, dia baca basic sebab dia berubah dia banyak paper lain pula dia punya pattern dia. Okay, ni ada WTG BSS ni. Contoh satu lagi Okay, this one. Tahu lah engineer mestilah tahu kan buat dia teacher review Takut ada yang tak kenal engineer takut tak tahu pula siapa. Takut ada yang tak tahu sense direct. What's the sense direct? Okay, jap. Come back. Ayuh. Okay. Paper energy, for example. PV, WTG, BSS, DG. DG tu distributed generation ke? WTG is wind turbine generator. Abbreviation for the wind turbine generator is WTG. Oh, first time saya dengar. Battery storage system is the BSS, KBSS, and DG I think that's distributed generation. Bukan. Oh, sorry. Silap. Diesel generator is DG. So they have the combination of hybrid system, PV photovoltaic, wind turbine generator, battery storage system, and diesel generator. Baik kau, sempat. Okay. So 4 system, and they use the MOS, okay, MOS, metal oxide semiconductor. And then they have diesel generator there, and they have the PV, and the wind turbine, and the battery storage system. This is battery. I think I explained you before. For the larger capacity of battery, it looks like this. Besar sikit. Gambar tak nampak. Okay. Nampak ni. The battery like this . The size of the battery dia tinggi. Okay, it's taller than the normal, the black type 100Ah or 200Ah capacity of the battery. That's it. Size dia lebih besar, dia panjang-panjang, tinggi-tinggi. Okay, tinggi-tinggi. Energy management system, alamak. Tak kecil-kecil lah pula dia. Okay. Then modeling of PV, battery DG, dia compare lah. So ni contoh ada inverter, bagus ada gambar-gambar ni kan, menarik sikit. Then equation there, ni SOC ni state of charge. When we play with, okay, one keyword that I can share here. When we play with the energy management system, you are definitely to see this kind of abbreviation, SOC. What is SOC? SOC is the state of charge. What is the state of charge? Is the remaining energy level in the battery. Macam tu. AH lah, that AH lah. But SOC in percent, the basic unit is a percent. But it's about the energy storage level in the battery is measured as state of charge. Okay, state of charge. Persen tu lah, yang persen yang battery tu. Battery level 10%, 50% tu lah dia, state of charge. Okay, when play with the energy management system, we play with the state of charge. Okay, kalau you nak tahu detail lagi, you Google lah. Ni average mean speed, ini average solar radiation. So this the solar radiation ni, UGM pukul 12 dengan pukul 1 ni, waktu Zohor ni. So kita waktu Zohor ni is the maximum peak time, where the maximum power, maximum energy can be generated through that. Okay. Ni contoh paper lah, dia pakai control tu untuk control dia punya output dan sebagainya. Ni adalah graf-graf dia. Lepas tu ada punya beberapa equation yang related to here. Saya nak tunjuk-tunjuk kat awak macam tu. Okay. So finish already for energy management system. Kita dah tengok lah beberapa paper yang berkaitan. Okay. Another one is the smart grid. Okay, smart grid. What is smart grid? It's different to the distribution generation generation. It's not the physical. Smart grid is more to one place that have the best storage banks, PV, ada diesel, ada wind. In community tu, there's a smart grid there, and everything is monitored using the SCADA, using the system. Everything properly managed lah. But based on the PV, and there'll be the storage banks there. Dia macam satu one committee that have all the energy is the renewable energy, sometimes so related to that, and then they have the storage banks, battery, a very huge size of storage banks to facilitate certain region or certain community. So memang by default maksudnya macam tu lah. So penetrating the energy output of hybrid PV wind renewable energy system using feature selection technique for smart grids. So basically for the smart grid, they are going to embed the PV system, wind system, and the batteries also. Most of the cases. But they are the storage banks. In smart grids, there are the storage banks and properly distributed to the housing and the community. Okay. Boleh Google lagi. Dia ada smart grid, ada micro grid. Lepas tu dia ada mini grid. Tak pernah dengar lah. Micro grid atau smart grid lah. Yang ni guna PV. Then there will be the control also there. They use the artificial neural network. But they use artificial neural network as the prediction the energy output lah. Like I told you, because when we solely depend, not solely, but when we majorly depend on the PV system, it's very critical to have the prediction system, forecasting system. Forecasting of energy is very critical because if we can't predict, if we don't know what will happen in the future, let's say the heavy rain for the longest days, we are going to have problem. The whole community will face a problem because we don't have backup. Okay, we don't have enough backup. PV already down because of the weather is very cloudy and rainy. So we depend on wind. But in heavy rain, sometimes it cannot turn well the blade, for example. Maybe dangerous, something like that. And then sometimes maybe they shut down. So the will totally depends on the storage battery, storage bank. So that's why very, very critical. Smart grid, the control, the same with the energy management system. So I bring you first from the hybrid and then energy management system, and the hybrid energy management system to facilitate certain area of community. It is called as smart grid. Macam tu. So relation between that three. Ini they use the artificial neural network. Okay, they have the multi-layer, multi-layer ANN regression. For those who play with the ANN ni familiar kot. Ni ANN punya regression standard model prediction. Then they boleh using the absolute area, mean absolute area and mean square area. Mean square error, error. And then there's the macam dia data accession, feature selection, training models. So they train using the ANN. And then they keluarkan output temperature berapa solar radiance. They predict the solar radiance and the temperature to humidity, something like that. And then, so dia buat estimation, prediction lah. Prediction of energy. It's very important for the smart grid system lah. Ni macam apa lah. Ni graf kamu ni, tak tahu. Ni contoh paper contoh paper. Example of paper that relates to the smart grid. You boleh cari lagi lah smart grid yang lain. Okay. So habis dah cak senang. Hybrid system. Okay. Google aja hybrid system tu hybrid confirm Energy management system tu dia play with the control. But the real application is on the smart grid. If we can properly manage energy management system for small scale and then we already mix up all the hybrid system, all the energy resources in one system that we call it as hybrid. And then it's the real application is the smart grid. So that's our target. But I think it's not smart city. I'm not sure about smart city. Maybe related to smart city juga lah. Memang totally it depends on the system tu, grid tu. Memang dia standalone. Okay. They establish their own grid. Would be properly manage and control of the output and input, and also it requires also prediction for the energy in future, something like that. Any question? Satu lagi saya nak tunjuk, ni. Any question? Ada apa nak tanya, benda-benda lain pun boleh. Hello. Nafis, any question?
No question, sir.
No question Nafis boleh lah establish smart grid dekat ni, Langkawi. Langkawi kan pulau. Tak sendiri belakang rumah. Kecil-kecil, 3-4 orang dari komiti lah, boleh dah. Tapi mungkin saya ada kecil sikit lah, dia panggil microgrid dan sebagainya. There's a scale there. Haziq, any question?
Tak ada, sir.
Faiz bin Gamil, any question?
No question.
No question. Firdaus Rusli.
Tak ada sir.
Tak ada. Oh, sekejap makan nampak. Ni macam makan ni. Okey lah, dah nak tunjuk Saja nak tunjuk sikit. Nanti yang nak detail boleh Google lah. Okay, boleh tengok balik. Okay. So this is the SEDA website. SEDA is the Sustainable Energy Development Authority. It's called as SEDA. Okay, this is SEDA. What I'm talking about. It's about SEDA semua tu kan. Okay, this is SEDA. Okay. So the official website of the SEDA. So from top above here, there will be some menu like net energy metering. Okay, the scheme provided by the government through the SEDA authority ni. And then feed-in tariff you don't have anymore. Feed-in tariff and large scale solar is for the system, I think more than 1 megawatt system is called large scale solar. Okay, LSS ni LSS ni. And then there will be the safe consumption dia bunyi macam net energy metering tapi dia lain lah. Okay, dia tak ada tidak berlaku jualan. Safe consumption ni diguna untuk dia sendiri. Okay, but the most yang tu you boleh tengok lah yang LSS contohnya. Tapi yang what I'm going to highlight here is about we call that as net energy metering. I think some of you already hear about that already. But this, now we are in the 3.0. Where is the 2.0? I think 2.0 2 years before maybe forgot. Okay, 2.0. Kat sini dia ada kot, dia bagi link 2.0 kot. Saya dah jumpa, mana pergi lah. Tak apa. Kita cerita sekarang dengan 3.0 lah Okay. Ini mesti ada. Delivering a greener future. Okay. So government introduced the net metering in November 2016. Okay. With quota allocation of 500 megawatt. Lepas tu 2020 ni encourage the energy uptake. And then start from 1st January 2019, if you still remember lah. There's we call that, I forgot the I forgot the name of the minister, but Yeo Beng Hing maybe. So she introduced a new, the new renewal, what you call it? The concept is new concept is renewed on NEM. What is that? Kita tengok idea ni The true net energy metering concept was adopted where, okay, dari sini from here, where it allow access solar PV generated energy to be exported back to the grid on a one-on-one offset basis. Okay, before 2019, net energy metering, I think, has very less popularity compared to the feed-in tariff. Why? Because the exported back rates is very low. Okay, it's not that much. I think very low, quite low lah. The low price is given for those who export back to the distribution. Okay. But when it comes to the 2.0, NEM 2.0 ni, they revise, they're led by the YB Yomihin ni, to revise it back so that the payment for any excess solar generated from our home, we export it back to the TMB. The payment, the payment that we receive, or the price that we receive to, will be based on 1-to-1. 1-to-1 means ikut tarif TMB lah. TMB tarif. For example, the first 200 kilowatt hour 28 cents. Saya pun tak ingat. 28 cents, and then 33, the next 100 kilowatt hour 33, and the next 100 kilowatt hour and above 55 cents for example per kilowatt hour. So when they renew NM 2.0, then if you have, for example, 100 kilowatt hour of excess energy, you export, automatically will be exported to the TMB, and the TMB will pay you based on the first 100 kilowatt hour, for example, 28 cents. So 28 cents multiplied with 100. Okay, 100. So but per kilowatt hour, 100 means that you get 28 ringgit lah. for every 100 kilowatt hour, for example, in as a profit. It comes as a profit because you use energy first, you generate your energy first, you use, if excess energy, I think at the end of the day, something like that, then it will be forwarded to the next month, or it will be rewarded, credited to your account. Okay, credit to the account. And then based on the 1 to 1 to so bila 2.0 ni baru start from NEM 2.0, then there will be lots of applicants, lot of application, lots of tenders has been open, lots of companies to involved with that, a lot of contractor company related to solar installation only. Now it's increasing, boleh tengok mana-mana solar banyak gila solar company yang buat installation ni. Buat design installation for the NEM. Due to this, before 2019 tu, I think we focus on feed-in tariff, and feed-in tariff finish. Dah habis. Feed-in tariff tu sebenarnya paling masyhur lah. Sebab I think there's some season you can get per kilowatt hour RM1. So imagine if you get 100 kilowatt hour per day excess energy, you're going to get RM100 sehari. Contoh kalau 100 kilowatt hour lah. 100 kilowatt hour per 1 ringgit per kilowatt hour. Until that rate at the time, I think 2016, very old lah. Now, feed-in tariff already finished. So here come phase 2, NEM, and also large scale solar. But for the case of large scale solar ni is for the solar farm size, 20 megawatts, 100 megawatts, 50 megawatts. And the rate, if I'm not mistaken, recently, very recent, I heard from some consultant, I think 17 cents or 13 cents per kilowatt hour. Imagine you only get return. The TMB only pay you 17 cents per kilowatt hour. Ui, bayangkan. No matter how much you generate, it will be multiplied with 17 cents per kilowatt hour. So that's scale for large scale solar. But I think they have a different scheme lagi lah. But the rate like that lah. That's why large scale solar ni it's not that for people like us, maybe it's not suitable lah, because some one is not really profitable lah. It's not really profitable. It's actually helping the TMB to become one of the energy provider for the TMB, and TMB dia sell to the consumers kan. Macam itulah. Okay. So the NM 3.0, what is different? Dia ada beberapa package. Saya macam promote hari ni. Okay. So this is what the NM 3.0. But still will be based on 1-to-1 basis tadi. Still. But it separated into several schemes. Okay. Boleh lagi ke? Okay ke? Ke dah tidur dah? Lim singing.
Yes, okay, sir.
Still intact Pandang-pandang lah. Boleh lagi
Yeah.
Okay. In case after you finish, you graduate, you go to the solar company, for example, that play with the design. These are the project, or this is the scheme that mostly used by them to install the one is large scale solar, and another thing is the NEM rakyat, NEM government, the NEM Net Energy Metering Scheme. Okay, kita pergi yang rakyat first NEM rakyat. Okay, NEM rakyat, the quota is 100 megawatt AC. 100 megawatt AC mean the total quota for the, I think the year 100 megawatt AC, then in one Malaysia lah. That's why people are applying for that. But NM rakyat, the term also rakyat lah, citizen. So citizen, there's a capacity limit lah. Okay, capacity limit, tengok sini. Capacity limit is for single phase. Ni macam jual, saya macam jual barang. Gitu. Okay, for single phase, only 4 kilowatt AC. Okay, 4 kilowatt AC means that 4 kilowatts of energy, 4 kilowatt of power will be exported to the TMB in AC. Okay, in AC. Means that our system, our panel maybe can become 5 or 6, something like that. But the exported one is 4 kilowatt AC lah. Okay. For the single phase. For the three phase is 10 kilowatt AC. Yeah, 10 kilowatt AC for the three phase. So for those who have the three phase wiring system, the wiring phases you have three phase, then you can go up until 10 kilowatts AC lah, to be exported to the TMB lah. Okay. Ni macam nak belanja kan. Will be consumed first, which implies that less energy will be imported from the distribution. Remember, implies that's less energy will be consumed first. NM consume, basically NM ni konsep dia, kita generate untuk digunakan untuk kita access energy per day yang kita dapat tu baru di export ke TMB. Okay. Dia macam kredit berapa hari yang kita generate, dan dia akan lebih tu akan jual. If I'm not mistaken, they can the contract, I think contract is about 10 years contract with the TMB, the one-to-one offset basis. Okay. The credit shall be allowed to roll over for maximum of 12 months. Access energy tu saya rasa dia akan kira per month lah. Per month. Contoh, saya beri contoh dah, saya tahu betul tidak contohnya sesuai atau tidak. Contoh. Our house, let's say kita ada 10 kilowatt AC system maximum yang kita fit every instantaneous. So 10 kilowatt tu maximum lah power kita fit dekat TMB. Maksudnya kalau maximum pun 10 kilowatt lah yang kita boleh fit per hour. 10 kilowatt hour. And then we generate, for example, 4 hours per day, then we get 40 kilowatt hour, right? 40 kilowatt hour per day. And then in one month, let's say 40 kilowatt hour, then multiply with 30, and then maybe we get 1,200 kilowatt hour per month of energy generated through our 10 kilowatt AC system. Okay, so our installation, we install the panel maybe around 12 kilowatt AC, 12 kilowatt DC, but export to the TMB 10 kilowatt AC, and per day we are going to generate 40 kilowatt hour of energy, and then a month multiply with 30, you get 1,200 kilowatt. Let's say we use aircon, everything, we use like my house for example, 500 kilowatt hour. And there will be remaining of 700 kilowatt hour. So that 700 kilowatt hour will be exported to the energy, to the TMB. Okay, I think in credits, they're giving you in credits. And then you can bring it to the next month. If I'm not mistaken, dia akan tolak, dia ada reduction. Tolak, lebih tu bawa. Carry forward until 12 months. 12 months only. After 12 months, for example, you tak guna kan? Accumulated, contohlah you use, then you get 500 kilowatt every month, for example, itu memang extra lah, 500 kilowatt hour. In 10 months you get 5,000 kilowatt hour kan, 5,000 kilowatt hour of energy. Okay, sudah dari segi untung tu mungkin dah untung aku dah free, billing kau dah free kan. The next, and then 2 months, 12 months, accumulate lagi dalam 6,000 kilowatt hour. Tak guna, burn. Tak guna burn. Macam tu. Sebab dia kalau kita, okay, however most domestic customer may not be at home during the weekdays and may have excess energy exported to the grid. The credit should be allowed to roll over. Okay, priority is for self-consumption. Ingat, the priority is for self-consumption. However, most domestic consumers may not be at home during the weekdays and may have excess energy exported to the grid. Then credit should be allowed to roll over for maximum of 12 months. Sebelum ni saya rasa 24 months, if I'm not mistaken, ke 12 months. So dah limit lah. Kredit dia tu boleh tahan 12. Kalau tadi lebih kan, lebih betul kau tak pakai pula kan. Dia bil jadi free, free. The 12 months tu senang cerita, bulan yang terakhir tu kau buka aircon lah sepanjang masa. Kau punya guna kan, bau. Tidak, dia akan burn. But I'm not sure lah. Maybe we can deal if 30 months ke boleh deal balik dengan TMB kot lah, boleh adjust kan untuk dibawa sikit ke, tak tahulah, saya tak pasti tu. Itu saya tak pasti, tak pernah try. Kot lah boleh bawa kan. Tapi basically dia di 12 month. Ini NEM, the NEM things that I need you to know. Ni memang tak ada dalam syllabus pun. Tapi saya ajar juga. Saya rasa benda ni penting kalau siapa yang interested in the kalau pergi solar company ni, ada you tahu benda ni, orang tak boleh tipu you. Okay? Okay, ni website. Faham ke Khairul Nisa? Khairul Nisa?
Faham, sir.
Faham Ya, tanya saya kan. Fatin,
Yes, sir.
Fatin faham? Fatin ada soalan? Nak tanya ke Khairul Nisa? Tak ada? Tak ada Tak jelas tak apalah. Fatin, okey Fatin, nak tanya soalan? Fatin Kristina. Ada nak tanya Sufi Razali, ada nak tanya apa-apa ke?
Setakat ni belum lagi tu.
Lagi kau lepas ni masuk solar company, kau nak fight tender semua, itu tender tu cerita lain lah, itu industri level lah. Tapi nak cerita yang tu cerita lain, cerita skim yang ada dulu kat Malaysia kan. Alright. Okay, habis NEM rakyat, so kita pergi kepada NEM government lah. NEM rakyat, NEM 3 phase dapat 10 kW AC je lah yang kita boleh maksimumkan export to the TMB tadi lah. 1-to-1 basis. Okay. And then new government nama dia, new government. Okay. New government is the for commercial lah, for commercial. Kalau NEM rakyat, nama citizens. So dia untuk household ataupun domestic. Okay, domestic ataupun household je lah. Tapi yang new government ni untuk commercial. Okay, commercial, what's the maximum size given here? The maximum capacity of previous station shall not exceed 1000 kilowatt, which equal to 1 megawatt. So 1 megawatt is the maximum one lah. Okay, for medium voltage consumer not exceeding 75% of the maximum demand. Okay, ini untuk yang medium voltage MV punya consumer lah. Low voltage consumer macam saya rasa shop lots biasa kot. Not exceeding 60% of fuse rating, director, current semua, bla bla bla. Okay. Tapi ini the main important things is the 1000 kilowatt. Okay, 1000 kilowatt. Tapi dah ada detail perincian lagi lah. Tapi ini government ni untuk commercial value lah. Commercial value lah. Untuk commercial punya industry. Shop lots pun boleh. Still lagi 1-on-1 offset basis. Still the same. The different only government is for the company lah. Ataupun commercial buildings. Hotels commercial. Boleh juga. Restoran yang besar-besar kan. Restoran runcit-runcit. Kalau domestik dia masih okey lagi lah. Tapi kalau yang shop lots yang heavy ataupun department store kan, department store like Giant ke TMG something like that, that one maybe they can apply for the NEM government. Sebab dia dapat 1000 watt kilowatt. Ini dia tak cakap pun kesama juga. Still the same, 12 months. Like still the same 12 months. But this one is license is required under section 9. It's supply act for any person use, work or operate or permit to use, work over, operated solicitation over 72 kilowatt peak for 3-phase system and for single phase system. Ini kena ada license untuk 72 size besar. Tapi tak apalah, ini bukan kaitan dengan kita kan. Ini pasal ini commercial lah. Commercial punya backgrounds. Okay. Last ni Nova. Okay, Nova is the concept net offset virtual aggregation program. Okay, Nova ni I think still the same ni. Saya rasa 1 megawatt maximum. Tapi dia ada menarik kat sini lah konsep Nova ni. Net offset virtual aggregation. Bunyi aggregation tu kan, segregation dia bunyi. Is that the energy produced from solar PV on the Nova consumer premise shall be consumed and designed primarily for self-consumption. Any excess energy is not consumed at the premise where the premise is located, the distribution constraint or much needs in a very not demand at the same may be exported through the supply system under one of the following categories. Okay. Kategori A dan kategori B. There's two. Kategori A and kategori B. Kategori B. And then contract sama juga 10 years. NEM tadi also same 10 years contract with the TNB. Okay, 10 years. And then, okay, ini yang menariknya ni lah. Kategori A ni, any excess energy produced in a month which is not consumed by the Nova may be exported by the supply system to the distribution licensee, which means that any excess energy not used, as any excess energy that are not used will be exported to TNB, senang cerita. Okay. Produced in months not consumed by may be exported via the supply system to up to 3 designated premise. Ada lain sikit. Kategori B ni ada lain sikit. Kategori A ni bagi kepada TNB lah. Tapi kategori B ni dia lain. Dia kita boleh forward ke 3 designated premises. Any excess energy tu. Benefit ataupun profit dari situ. Value of the energy should be credited to the account of the Nova consumer. Okay. To offset the bill payment for the next billing period. Maksudnya dia bawa kredit ke hadapan lah. They bring the credits, carry forward the credits, and then it will be free like that. Okay. But for Nova category B, the value of the expected energy should be credited to the account of such designated premise to be used to offset the bill payment for the next billing period. Wow. Designated premise. Contoh saya beri contoh. Saya tambah sikit bawah ni. The unit price of the energy supported in the billing period to the supply system should be based on the average system marginal. Unit price ni sama juga, should be based on average S&P, sama. A designated premise of the Nova consumer includes premise used or operated by its wholly owned subsidiary company. Okay. Dia macam ni. Kalau kategori A, contoh saya kategori A, saya generate dekat contohlah saya ada company lah, saya ada company. Okay, saya ada company, saya pun pakai Nova ni, saya ada company. Kes kategori pertama, saya ada company dan saya access energy, guna semua aircon dalam, lebih energy tu bulanan dia bawa carry forward. Maksudnya kita jual ke TNB, TNB return in credit. TNB give us credits so that it will be carry forward to the next month billing. So akan free generate next month. Okay, finish. So means we go to my account. Okay, when number 3 ni designated premises. Contoh, I have company Syahiman Sendirian Berhad, but okay, Syahiman Solution Sendirian Berhad, and then I have company Syahiman Solar, Syahiman Cafe. Contoh, saya ada Syahiman Solar, Syahiman Cafe dan Syahiman Kindergarten School. Contohlah. Okay. Ada 3 premises, but still under mine. Under Syahiman Solution Sendirian Berhad, they have the subsidiary company below than me. So adalah saya ada superior ni, adalah budak-budak saya bawah ni kan. Satu yang jaga kafe, satu yang jaga solar, Syahiman Solar tadi, and then jaga Syahiman Kindergarten School sebab nak elak tax sebenarnya. Kita buat kita buat macam buat amal sikit lah kan, kita buat Kindergarten School. Okay. That generated from the Syahiman Solution Sendirian Berhad, contohnya pusat di Putrajaya, dia boleh bring forward, boleh bawa kredit tu kepada setiap tadi. Syahiman Solar dapat sikit, Syahiman Cafe dapat sikit, Syahiman Kindergarten School pun dapat sikit. Jadi tiga-tiga tu pun bawa company saya, so dia punya bill itu pun saya boleh tolong top up lah. So saya top up sikit, so dia ada kredit. So mungkin tiga-tiga kalau generate kat tempat saya mungkin banyak kan, besar sikit sistem contohnya. Kita ambil yang commercial punya value boleh sampai 1 megawatt contohnya. And 1 megawatt tu yang excess energy tu semua kita forward, bagi-bagi. Contohnya mungkin banyak pakai kat cafe sampai tengah malam, Kindergarten School sampai siang. Jadi saya forward lah. So benda tu boleh forward kepada premise yang berbeza. So ini adalah Nova. So ini konsep Nova. Dia boleh forward pula. To forward kredit tu boleh pergi kat dedicated subsidiary company tadi. Tapi still register bawah kita lah. Macam tu. Tu je kot aku nak sembangnya. Yang lain baca sendirilah Kota tu salah saya 100 megawatt AC. Setakat ni telah digunakan 25.4 35.5 megawatt 35.5 megawatt kota ni. So ada lagi dalam 74.5 megawatt kota AC untuk NEM rakyat. Okay, NEM rakyat. NEM government sama juga. NEM government ada 80 megawatt AC, sama juga, ada lebih lagi boleh apply. Nova, Nova besar sikit. Nova mungkin 500. Ya ke 500? 600. Nova ada 600 megawatt AC. So ada lagi boleh apply. Contohnya kita nak apply Macam mana saya nak apply lah macam mana sesuai? Confirm lah kita sesuai dengan NEM rakyat. Okey, yang cerita pasal NEM calculator, kau ada klik kat sini. Nanti boleh pergi calculator. Ni saya bagi just untuk kalau awak berminat lah Kalau awak mungkin berminat je lah boleh lah. Kalau orang tanya pun boleh dah sembang, dah boleh kemas dah lah. Saya tunjuk benda ni. Ni contohnya kita ambil domestic tarif. Okay, domestic tarif and building type. Contoh rumah terrace house. Lepas tu average electricity bill months, let's say lah kau letak 250 sebab banyak pakai aircon. And then mau purchase sesama PPA. Okay, PPA is power purchase agreement. Then solar energy rate in PPA. Alamak, ni apa lah? Tak tahu lah. Cuba tekan calculate. Energy rate 3% ke? Okay, ini estimation Kalau you nak tahu secara detail quotation lah. Okay, you minta quotation dekat company yang ada solar ni lah. Macam saya cakap, ada beberapa grup Facebook yang ada grup solar lah, grup buat sendiri lah, solar DIY lah. Boleh you try tanya in case interested lah. In case interested. Contoh you nak 4 kilowatt. Tadi kita kata boleh 10 kan. Tapi ni dia bagi 7 kemudian. Okey. Yang ni contohnya proposed install capacity 7 kilowatt peak, tapi kita punya B 200.5. Tapi kalau you punya rendah lagi lah. Yang ni your monthly bill after NEM 190, sebenarnya jimat 60. Sebenarnya tak cukup lagi lah. Kena tamat. Tapi ini is just the estimation lah, estimation. The correct one, yang ni ada rate ni. Ini rate dia. But the correct one tu sebenarnya you asking the company yang related lah. Nanti dia do the calculation for you. Dia akan bagi berapa dia nak tanam berapa kan. Berapa duit yang you cover lah. Okay. Ni kiranya penjualan memang saving RM60. Ni tak cukup lah kena test lagi. Macam tu. Ni ada dekat ni calculator. Kalau you buka tadi, dekat bahagian calculator. So ni boleh you main-main lah. In case lah you, at least orang tak boleh tipu kan. You tahu sikit ni jadilah kan. Semuanya kita ada sedar ni. Kalau tadi tanya saya lah, kita aim for NEM rakyat lah dia. Dapat 3 phase ke? Dapat 10 kilowatt. Lepas tu, tapi nanti you, like I told you, you need to ask the quotation from the company. Sometimes they give you, for example, macam sebelum ni berapa lah, saya tak ingat dia punya nilai berapa. Ada yang 5 kilowatt ke 4 kilowatt. I think now 19,000, 17,000 tu boleh dapat 4 kilowatt peak of the system. Lepas tu nanti you kena kira pula you punya RIM macam ni. Nanti dia do calculation for you lah. Itu saja sekadar nak dapatkan information, apa nama tu, untuk you ilmu lah sedikit. Apa yang saya tahu, saya share sikit lah. Okey, jap lah, last. Okey, ni you boleh buka ni contohnya LSS large scale solar. Large scale solar ni berat lah untuk jap. Berat. Nama dia tak ada, tulis banyak lah. Overview dia tak banyak. Dia ada guideline, tak apalah. Guideline kau tengok lah nanti. Cek lagi lah. Saya tunjuk satu lebih kat awal. Okay, last. Sikit. Just untuk okay. Alright. Ini so this is the courses that provided by the SEDA relate to the PV system. Yang ni yang beberapa course yang provided by the SEDA lah. Contoh we have learned grid connected design kan. Saya cakap tu terang. Grid connected design saya tunjuk buku tu. Ni dekat sini. Ni dia. GCPV Systems Design Course. Okay. Ini yang design untuk grid connected kita belajar tu, inilah dia contents dia kalau yang tahu. Okay. Dia punya harga mana? Tak tunjuk harga. Okay, tengok harga dia. RM5,660.40. Untuk 10 days kot. Saya rasa 10 days. Dia ada dekat UiTM, dia dekat Selangor HRDC. Okay, SHRDC kan. UiTM Shah Alam, saya rasa UiTM Shah Alam ni. UiTM Shah Alam dengan HRDC lah. SHRDC. Ni training ni, if you pass there will be the exam, I think the 8 days course, yes, 8 days course. Design connected is actually hampir sama dengan yang you belajar sekarang ni, cuma ada part-part yang saya tak semualah tu. Kalau you kena kalau you pergi detail tu nanti dia akan bagi buku tu, the full book tu. Tapi apart from that, yang apa kita design semua tu based on the module from here lah originally. Ini yang untuk orang pergi ke nak buat LSS semua, designer tu yang ada ilmu ni, kiranya ada ni, dia boleh pergi freelance lah. Okay. Dia ada dah punya course, dia punya cerita dia punya course ni. Ni dia RM5,660.40. Another thing, for Wyman and Judgment ni different thing, GCPV and also OGPV kot. Saya nak tunjuk OGPV. Mana ni OGPV. Another thing is the off-grid system design course. This is for standalone. Sebenarnya ada juga saya justified. I told you, I only confident to teach you in the grid connected system. Sebenarnya standalone pun ada book dia, tapi kita ada guideline dia dari sini juga. Tapi kita tak ada lagi yang siapa yang ada, yang ada certificate ni. Ini agak mahal sikit, RM7,000. Okay, RM7,000. Contoh tadi yang RM5,600 tu still you have to sit for the final exam. Tapi kalau repeat yang dia tulis siap. Repeat teori yang practical exam ada harga dia. Repeat dia ada berapa ratus lah. Macam kau ambil ni lah, kau repeat course kan, bayar kan, ambil short sem. Macam tu lah lebih kurang. Cuma tadi yang ni lah, yang kita belajar grid connected is all in the GCPV system design course. And inapplicable in Malaysia case lah. But I think if you bring outside, if for those who are not, for those who are foreigners, mungkin boleh bawa, you can also bring your country, maybe, okay, if they can recognize that, okay. Basically yang ni lah, ni contohnya murah sikit, RM200. Dia ambil subjek kan ikut kredit kan, kredit 60 kan, 60 multiple 180 no different lah. Okay, itu saja untuk pengisian kali ini. Saya pun for any question, if we have class on the next Monday, I will let you know. I try to arrange. If the better one, if I can, if not possible, I try to do the synchronous one if possible lah, yang previously. But the better one is to do the synchronous session. But officially kelas kita habis kat sini. Okay, Rabu ni sebab nak test kan, untuk preparation for your PSM1 seminar. So I wish you all the best. For the next week also, for those of SM2 also excellent. I wish you all the best lah. Any question? Boleh PM saya juga. Any question?
Tak ada saya.
Tak ada. Boleh faham Syahadan?
Allah boleh saya.
Boleh masuk company solar insya-Allah. Boleh try At least I hope the small sharing that I did just now or until now, until today, I think at least beneficial for you, not only for the exam lah actually. Maybe you will use in when you start to job. If you find the job related to that solar, maybe it will be beneficial. Maybe, I hope. Zulfikri.
Ya saya.
Question.
Tak ada.
Boleh faham?
Boleh.
Boleh ni tak ada exam pun, tapi boleh lah try cuba kod-kod lah. Ada bajet lebih, kod-kod nak sponsor saya pun boleh juga. Jelas. Lai Chong Jing. Any question?
No, sir.
Okay. Ho Chia Hui.
No, sir.
Fatin Nadia.
Tak ada, sir.
Okay. So official, our class finished today officially. I mean, but the previous list, if we have session, then I will tell you later. And don't forget the quiz 3, quiz 4 and the assignment. Assignment tu boleh negotiate lagi lah. Tapi jangan lama sangat. Nanti saya nak marking semua tu ke laut juga ni. Kalau lewat-lewat pergi. Okay. If no question, then if we have some question, other question, you can just PM me lah. Okay. Just message in the private WhatsApp. Okay, thank you. Good luck untuk siapa yang akan present nanti. Selamat berjaya.
Thank you, sir.
Thank you, sir.
Thank you, Doctor.
Right.
Thank you, sir.
Right.